All right. So suppose that we are driving a car and we are driving 90 miles and we have one quarter tank of gas, and the tank holds 12 gallons, and the car averages 25 miles per gallon. I want to know, am I going to make it all 90 miles before I have to stop for gas? And so what I need to do is I need to take the various quantities I have here and combine them into a single conversion factor. So we're just going to move that over there, and I'm going to grab a different color. Let's try red. So here's what I'm interested in. I want to know how many miles I can go. So I know I've got one fraction that refers to miles per gallon, and then I've got a fraction that represents how many gallons are in a tank of gas, and then I know that I have 1/4 of a tank of gas, so tanks will cancel, and gallons will cancel, and I have miles. I get 25 miles per gallon. I have 12 gallons per tank. So what I end up with is 25 times 12 times 1/4. Well, that's 75. So I only can go 75 miles before I run out of gas, which means this is not going to work. Okay, now suppose that I want to keep a 100-watt light bulb on for 1 week. And I want to know how much this costs. Now, let's say that I know it costs 15 cents per what's called a kilowatt hour. And we're going to try to get quantity of money. So let's call that $0.15. Just do that conversion. And I am interested in my final answer being in dollars. So I know that that is $0.15 per kilowatt hour. I know that there's 1 kilowatt per 1,000 watts. What else do I know? I know that I am burning, I'm going to make this a little smaller. I'm running out of room already. Let's try this. That's a good place. Now, I know that I'm using 100 watts. We'll call it 100 watt weeks. So that is how much power you use. That's how much energy you use when you use a 100-watt light bulb for a week. So then I need to convert weeks to hours. So week is 7 days, and then I multiply 1 day by 24 hours, and what I end up with is 0.15 times 1 times 100 times 7 times 24, all divided by 1,000, and that works out to roughly $2.52. Let's try another one. One more. So here's a fun one. There are approximately 3 million births in the United States per year. How many births per minute are there? So births per minute equals births per year times 1 year for 365.25 days. That's to account for a leap year, times 1 day per 24 hours. And then I multiply that by 1 hour per 60 minutes. And stringing it all together, I get 3 million divided by 365.25 times 24 times 60, and that is going to equal, while I whip out a calculator, works out to roughly 5.7 births per minute. So that's about 1 every 10 seconds. Pretty cool. Yeah. Let's try another one. Here's a fun one. Suppose I have a distance of 60 miles to travel. Let's say that I go from point A to point B at 30 miles per hour. I want my rate from B to A to be at some speed so that my average speed is 60 miles per hour. How fast do I have to go on the return trip? So, well, let's think about this. The trick here is that you can't simply add the speeds together. So think about it, and I'm going to start explaining it now. So here's the problem. The idea is that if you travel at 60 miles per hour round trip, that means that you traveled a total of 120 miles in 2 hours. Now the problem is that on this route, if you go 30 miles per hour, that's 60 miles in 2 hours. So in order to get an average speed of 60 miles an hour, you need to get from B back to A instantaneously, which means that this is impossible. Can't be done. All right. Let's see. Try one more. Maybe here's actually a little tricky problem. Suppose you have a room, and let's say that room is 22 feet long and 18 feet wide. I have squares that are or rolls that are 100 feet long and 12 feet wide. And I would like to use, I have to buy the 12 feet and I can give myself a length. I would like to minimize the length of the roll. So I have 12 feet and this is X feet. I don't know what that is. So my problem is I would like to make sure that I only have one seam. So by that I mean that I don't want to have to cut this into a whole bunch of different pieces to make it fit. So what I want to do is I've got two choices basically. I can go like this so that this is 12 feet by 22 feet, and then I've got another 6 feet by 22 feet. Which means that I would need a total of 44 feet this way. Or instead, I could go this way, and I'd need 12 feet and 10 feet. My seam is there, and so there I'd need 18 plus 18 feet, which is 36. And so that's a little less. That's just sort of a tricky one. So now that I've done that, if it costs $28.50 per square yard, how much did I spend? Well, I've got 36 feet by 12 feet by $28.50 per foot squared. And notice feet, and feet cancel. And so then we simply need to figure out what 36 times 12 times 2850 is. 36 times 12 times 25. And so I get, this is per square yard. Duh, I'm being silly. I made a mistake. A classic blunder. So this is yard squared, and so it's 1. So let me make this a little smaller. I need to multiply by 1 yard squared divided by 9 feet squared to get the conversion factor. So I divide my answer by 9, and I get the slightly more reasonable $1,368. All right. Maybe make that look like an 8. But it's basically more the same. So I apologize again. This is really late. I hope it's some help.